So let's go ahead. Now, all right. Yep. So that did load up. So again, eventually what I'll be moving on to is here in Module 4. Scroll down to the Tuesday and Thursday lectures. Tuesday we'll be looking at random passwords. Or you can go to Runestone directly, log in, and go to the textbook, scroll all the way down to the projects, and we'll be doing Project 5 from the textbook. Okay? Anyway, now really so let's go into a bit more detail about the for loop now that I've refreshed your memory. What a for loop does is that it allows you to iterate over a sequence. So let's go ahead and elaborate that first term. What is a sequence? Okay. What sequences? Okay. A sequence basically asks the question and answers it. Can we stuff more than one thing into a variable? Like x is equal to 5, I'm stuffing one item into this variable. I am putting a single item into x. Technically, a variable can only ever... A variable? Really? Okay. Technically, a variable can only hold one thing. Okay? But if we make that thing a container that holds lots of other things, then we can cheat. We've seen this with one thing already, the string. Here, the variable word holds bird, which is technically 4 letters, right? It's 4 separate things. It is a collection of things. It is a sequence. Make sense? Right? And if it is a sequence, if and only if it is a sequence, you can iterate over it. So, well, probably closer to if it's a sequence. So, if it's a sequence, you can iterate over it. Watch. For thing in x, where x is a variable, print, we're going to start with x first, print thing. Okay? This will error, so don't bother writing it down. Right? It's going to yell at us saying, hey, the int object is not iterable, meaning we can't iterate over that. Make sense? We can't go iterate over an x, right? Can't iterate over 5. It's just a thing. There's nothing to iterate over. Sorry, it's just a variable. It's a number. You can't iterate over that. On the other hand, for thing in Word, well, what is the thing that we are iterating over? BIRD. It is each individual letter. Make sense? A sequence is basically a collection of items that can be iterated over. So, and it makes sense, right? One at a time. Each of these is one thing, BIRD. Okay? In our class, there's primarily just 2 sequences we deal with, and you've already learned one of them, which is the string. And it is very easy to just kind of just take what you know about strings and use them for the other one, which are lists. Now, I'm not going to fully go over lists today. We don't need to know how to add to them, or remove items from them, or similar things. We just need to know that they are things that exist that we can iterate over. Okay? But more on this. Notice that it just kind of iterated over it naturally. I can call this whatever, right? So long as I actually, make sure the variable matches, right? 4-letter in Word, print thing. It's not going to print anything out because thing doesn't exist anymore. 4-letter in Word, that's what I often use when I'm iterating over something I know a string is. That's fine if it has spaces too, right? See? You can just iterate over it. Does that make sense? Now, how does this work with, on the flip side, well, the other thing we can work with is a list, which I'll just simply call L because, as you'll see in a second, if I type list, it might be hard to see from your perspective, but that just popped up purple, which means Python is warning me that that is a word that it has reserved for itself, like print or sum. These are words for doing things. A word is, a string is just like a collection of letters, but a list is a bit more generic. A list can be, here I'll just be a bit further, numbers. It can be something like this. And we'll learn more about this semester, later in the semester. This is not going to be on the first exam. This is more to get good practice in with the for loop, okay? This is more about understanding how that for loop works and what we can do with it and getting comfortable with it. And also to help explain what is it exactly we are doing when we are using the range function, okay? So numbers, 1, 2, 3, 4, 5, 6, right? For n in numbers, print n. 1, 2, 3, 4, 5, 6. We print every number in the list, right? Of course, as I just kind of said, the list can be anything, and those types don't have to match. Here's me turning 4 and 5 into floats. It doesn't care. And here I'm turning 1 into a string, so I guess it really doesn't care. And then also I'm going to add in the word taco over here, because why not? Everybody loves tacos. Okay? So, and then it prints out each item in the list. Make sense? Today's exercise will deal with iterating over lists of strings. And remember that whole kind of idea of what we could do with strings, like where we experimented a bit and we said, oh, we could do apple plus banana, and that makes sense, right? We can add those things together and it will glue them together in the most obvious operation, right? Similarly, if I do apple, sorry, I hit enter too soon. All right, apple and 15 plus then another list, 5 and taco, and now cat. Right? I've got 3 lists. I've got 2 lists here. One with apple and 15, and then 5, taco, and cat. If I add them together, it will proceed to try to do the most obvious solution to it, which is just going to glue them together into a single list. Everything that a string does and operates is the same way a list will operate. Okay? So we will learn more about strings lists later. This is we're just going to be using them today as basically in this kind of format to iterate over them, and also to kind of do this with them. But the other reason I bring them up is what the heck is range then, right? So let's go ahead and generate. I'm just going to call this what, because it's going to be a big question mark for us. What is a range then? If I just simply set it to a variable, what happens? Ever try that? You can. Print what? Well, first off, if I just simply set this up to range, it's going to say it's a class for range. Okay, that tells me nothing, especially at this level. Tells me something though. Okay, range 0 to 5. Oh, that's super useful. Okay. Well, as I said last class, anytime you do a range number, that's actually short for this, right? Range from 0 up to, but not including 5. And so putting that in gives me the same details. And if I put in a 1 here, which is redundant, it will still print out the same thing, I think. Oh, no, it gives me a 2 there. It just tells me. But the idea behind a range over here is that back in Python, we're currently using Python 3. back in Python 2, what would happen is that if you did range from 0 to a million, right, it would automatically create a list of all the numbers from 0 to a million. And now Python's crying because it's trying to print out a list of size 1 million. Give it a bit. It'll stop crying eventually. Okay. But what it would do is that it would print out this. Is that it would give me a list that was 1 million long. And you'd think it's just 1 million items. That's not even like, we're not even getting in close to gigabyte territory. And yet we're like chugging away at it and crying like it's a gigabyte. Okay. It's still running, trying to print it all out. Python's when it comes down to it, this program idle is very inefficient when it comes to printing. Here's a bit more efficient. Print, squeeze text, 62 lines. There it goes. So it used to be that it gave you all these 1,000 numbers. But you really don't need all those 1,000 numbers all at once when you're doing a for loop. So they did a bit of clever programming where what range does is that this whole advanced thing I didn't even learn about until I was in grad school called the generator. And essentially, long story short, it's just doing the same thing it used to do, only it's giving you one number at a time, because you only need one number at a time. Much more memory efficient. So really, range is kind of sort of a list. It's just being smart about it. And that's why we can iterate over it. Okay? So, and if you really, really want that list, you can ask it for that list by using this. Just like you can turn anything into a string using the str command. Let me actually do that. It just turns the function call into the string. That's funny. All right. Just like you can turn anything into a string, you can turn anything into a list using the list command. Okay. So, but that's the idea here. Okay. So to summarize it up, to give our big summary, 4 item in sequence. Okay, let's go ahead and make them capitalized. That is the way the for loop works, for each item in a particular sequence. The range can be a sequence, which is a list, and that will just simply present you with a sequence of numbers. A list can be a sequence, in which case it will give you each item in the list in turn. And this can be a sequence. The string can be a sequence. Okay? I know that seems like scary, but this was also a very high-level review of everything. All right. So, let's go on to today's task. That's project 5 in this one. It is generating a password XKCD style. So let's take a look at this. Now, most password organizations are, corporate security. They just do what's easiest. Temple's actually pretty good because they actually follow this rule. They allow you, if you go to change your password in your Temple account, you'll actually notice that the longer your password is, the less funky requirements they need, right? Most passwords require you to put in basically like special characters, right? And then a number, and then like capitalization and the like, right? This is because idiots keep using password as their password, thinking, my password's smart. Nobody's going to be able to guess that password's the password. That's not what's happening. It's a computer algorithm trying to crack it. It doesn't care about smart or clever. There's other things going on there that you don't really know how understand how it's working. So, long story short, you might take if say your password is a word like troubadour, you might do some common substitutions of like a 0 for a O or a 4 for an A. You might capitalize some random things, right? And then you might add in that random characters at the end. I mean, that's what I tend to do, right? I add in special characters at the end and a number, right? You can measure uncertainty using entropy. That's kind of a measurement of in information. There's an entire field called information theory, and the way you measure uncertainty in information is entropy. And let's just assume for the sake of argument that there are basically 28 bits, which he gives. Okay? In other words, there's 2 to the 28th, he's calculating there's 2 to the 28 possible different passwords that could be. Big number, but takes about 3 days at about 1,000 seconds per guess. There's other things that he points out, but it is technically plausible to crack that. But for you to remember it, was it trombone or troubadour, and was one of the zeros a 0, and then you had some symbol? It's hard to remember. But on the other hand, say you choose 4 words from the dictionary that are fine and not too uncommon, like correct, horse, battery, and staple. That provides a lot more entropy because it's a lot longer. A lot more, actually. 2 to the 44th, it says. And because of the way exponents work, right, let's just go ahead and see that out. 2 to the 28th versus 2 to the 44, that's considerably longer. A lot more digits there, right? That's thousands and on thousands of times. So, approximately 550 years at 1,000 guesses per second. Difficulty to guess hard, but difficult to remember. Correct, horse, battery, staple, you've already memorized it, right? Through 20 years of effort, we've successfully trained everyone to use passwords that are hard for humans to remember but easy for computers to guess. XKCD is a wonderful webcomic, and the idea here is that you've got this way of creating passwords that kind of just stink. So, and now we have programs that basically create these random 16, 24 character random characters for you, but now you can't remember your passwords because you have to have the program do it for you. So what I was saying is that Temple allows you to put in passwords like this, and that's certainly a way you can do it. Just simply make take 4 words, and now you've got a long password that's really hard to crack. I do not recommend doing correct, horse, battery, staple, though, since that's a given. All right. So what we're going to do is we are going to learn how to make some random passwords. Okay? So first things first, we're going to need some tools to do this, to make an 8-letter password. What we're going to be doing here is using, just like we did with the Madhava-Leibniz sequence, we're going to be making an accumulator. Basically, we're going to take something and we're going to keep adding to it until we get our answer. However, rather than adding numbers to 0 to get a sum, we're going to be creating a password and adding letters to it. Now, first off, what's our equivalent to 0 when we're adding letters together? And that is this, the empty string, the identity. So the identity is an important part of any kind of mathematical operation. The identity when you are doing addition is 0. 5 plus 0 is equal to 5. The identity is the thing when you do an operation on it gives you the thing back. So here 0, anything you add to 0 gives you the other thing, right? Similarly, the identity in multiplication is 1, right? Multiplying anything by 1 gives you the thing back. In string arithmetic, shall we say, or string concatenation, adding anything to the empty string, a string of 0 length, right, just quote, quote, gives you the string. So we're going to start with an empty password. The other thing we need to know about, our other tool, is how do we create, our goal is to create a random password. Now, it's not going to be random if I choose it, okay? Myself, I want the computer to choose it. So how do I make the computer choose random stuff? Believe it or not, Python has an extremely easy way to do it. First off, anything dealing with randomness is going to use the library that I've discussed in my videos called random. Import random. Random will not be on the exam, I believe, but it is still useful to know. It will be a heavy part of later exams, specifically Monte Carlo, when we get into Monte Carlo stuff. But what random is used for is for two things, essentially. Generating random numbers and choosing random things. Technically, it's used only for generating random numbers, but it's automatically going to use those random numbers it generates to choose random things for us. So that's part of the reason I love Python. Other programming languages it really, really makes you work to make random do the things you want. Here, Python's like, yeah, I've already got the work for you. It's more efficient for me to do it anyway. So, import random. Password is this. We can just, and here's how it's this easy, right? I'm just going to show you with a print statement. Print random for the library dot choice to choose something, and then give it the sequence you want it to choose something out of. So this would work for a list just as much as it would for a string. Random.choice letters. Right, save and run. And notice now when I hit run, it's giving me a completely different letter at the bottom. T, Z, Z, L, Z, A, S, N, E. It's chosen at random. Now, if I wanted to actually store this, to actually, add it up, or add this on, right, I would do something like password is equal to what I previously had for my password plus random dot choice. And that would be letters, and I could randomly add a letter. And then it's not going to print anything because I forgot to print anything out. So let's go ahead and do that. Print password. Right. CO. So it's just one letter. And we kind of learned that, okay, we could do this by doing copy, paste, 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 paste. Whoops. Where'd that indentation come from? The indentation came from me not doing this, for not closing correctly. And that not closing correctly came from me not copying it correctly. 5, 6, 7, 8. We could make a random password of 8 letters just by copying and pasting and doing this. But why copy paste when you can use a for loop? That's part 1. So part 1, take this statement, make a for loop. Part 2, seems a little silly to just have letters, right? So how can I have it choose from letters and caps and numbers? And the answer is by making a new sequence. How do we make a new sequence that's all of these things combined? Well, to combine sequences, strings, you add them together. So go ahead and take a few minutes to put that together. Right? Right? You can just simply, the key there is to add your, to create a for loop. For here we're going to do we need to do it 8 times, so I'll give you that. For blank in range. 8 to create an 8-letter password. And then we do this. Okay? But we want to add more than just the letters. So how do we get the caps and the numbers in there too? Okay. I will go ahead and send a message while I am waiting for you to do that. All right. So, to put this password together, so that we can select from all of these things, the letters, the capitalization, and the numbers, we can add them together either over here, letter plus caps plus numbers. We have all these strings we can add together. And now if we run it, whoops, what did I miss? Letters. We get this. It allows me to generate just random gibberish. Or I can take these characters, so I can take these three strings, and I can make something called maybe chars over here, letters plus caps plus numbers, and then just simply put chars over here. Either way works. Let me go ahead and we see that we get a complete random password, right? It is random. Statistically random. As I mentioned, yes?
How come it doesn't
it combines all of these three things into one thing. Here, let me print that out. Print chars. Okay. It combines all these three things into one big thing, and then it proceeds to select a single item from that big thing. Now, what you're thinking of, if you want to select a letter and a character and a number, you would basically do something like random.choice letters plus random.choice nums plus random.choice characters. You'd basically say, sequentially, I want these three. Okay. Yes?
So I put the chars, right, and then did letters, cash, numbers, but sometimes when I generate the password, is it normal? Maybe it's still a question, but is it normal that sometimes the password that's generated does not include like a number?
Yes, that's random.
Okay.
It's random.
So it doesn't have to include a number.
Right.
Okay.
Randomness is weird for us, and it's hard for us to understand until we're used to thinking about in terms of randomness. Randomness does mean that basically anything in the domain can understand. One of the, for instance, falsifying election results in some countries. Numbers, results with the numbers, like if we get in voter numbers and we're a corrupt official trying to trying to fuddle with election results, right? We might put something in like this, and then we're like, we had 240 votes here, and then, oh, that doesn't look random at all. 7 and 2 over here and a 3 over here, those look more random. Actually, no, wait, that's we've got a 3, 4, 3. That doesn't look random. Okay, so humans have an idea of what they think will be random, but are actually not. Okay, because we would expect we'd expect some results to end with 5 and some results to end with 0 if they were all uniformly distributed. So we have this idea of what randomness looks like, which is to say not generated by a human, but some stuff will look like it's been generated by a human. And over here, notice that the vast majority, like here I've got 3 capitals, and, let's see, I had one generate that had like 7 capital numbers earlier and 1 lowercase letter, right? That was one of my results earlier. It's perfectly fine because it's just choosing things at random. If you noticed, I had, early on when I was generating the first letters, I had when I was rolling through them, I had Z flash on the screen, then U, then Z, then Z. I had 3 Z's almost in a row, right? I had a lot of Z's just in short order, and that just happens sometimes in the grand pool of probabilities. The other thing to recognize is that these are pseudo-random numbers, technically. While I say they're random, that's actually short for pseudo-random, because randomness is this whole philosophical thing about, the computer has to generate these numbers somehow, and it uses an algorithm, and if you know the presets for the algorithm, you could technically calculate that quote-unquote random number. What matters is that these numbers are sufficiently statistically random so that they can't be guessed if you don't know those priors. And that over enough runs, it will be evenly distributed. Now, I'm going to share this code so you can have this code to reference for the next part. Okay? And the next part says, now remember what I said about taking 4 random words and putting them together into one password? We're going to do that. So here, rather than having 3 strings, letters, caps, and numbers, okay, I have 3 lists, nouns, verbs, and adjectives. And we're going to make a 4-word password by combining these things. Now, this seems like it's a harder problem, but here's the trick. It's the same exact problem as what we were doing earlier. Remember what I said about lists and strings? They're both sequences, and anything you can do with one, you can do with the other. So you're going to approach this same one the exact same way. What does that mean? You need to combine them and use random.choice. That's why I shared the code with you. So I'm going to go ahead and combine. So I'm going to go ahead and take this, doop, 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 right? And I'll give you, and I'll just delete this portion over here. Import, right? And rather than characters, you want to work with your noun, verbs, and oh, come on. Okay. So you want to adjust what we did last time to work with nouns, verbs, and adjectives. And remember, any kind of operation, such as concatenation you did with strings, that works with lists. So go ahead and take a crack at it. We're looking for 4 words rather than 8 letters.
I don't really understand what he's doing now.
And cannot concatenate string and you want to do it exactly the same way. And maybe we'll call it words. So not by combining them like that, but exactly the same way we did as the previous one.
Okay.
Make sense?
Got it.
And so now, if we do words over here, make sense?
Okay, thank you.
And so we have limit extreme statement relate.
Cool.
So, and then if we just simply move this out, we only get the last part.
Oh, really? Why? Is
Okay.
that
We
just
were
'cause?
because we were printing when it was inside the for loop.
Okay.
So we add a word, then print what we have. Add a word, print what we have.
Okay.
And here we're just simply add a word, and if we do it like this,
Just prints the
it's out of the loop, so it
yeah.
prints it after the loop is done.
Got it.
So
Alright.
it's the difference between it being inside and the difference between being outside the loop.
Thank you.
Oh, careful, careful, careful. And don't worry if you're stuck. I plan on going over this space again. And the way this works is that we do it, and then I go over the answer. We do it, then I go over the answer. Yes. You should be over here in this exercise. So go over here. generate a password XKCD style. And then what you can do, and because you can see, I should have shared this with you, so you should be able to get it.
Run this one.
So you can run, so. But yeah, we just did this one. And let me make sure I shared that. So, share code. I think I hit, oh, I'm not logged in? Interesting. Share code. Could have sworn I was logged in. Did it log me out? Let's find out. Can I go to the instructor's dashboard? I can, so obviously I'm logged in. What are you talking about? Share code. It's convinced I'm not logged in. All right, we're gonna just close this, open it up. Give me a second, I'm gonna go and log in so that I can do. Okay, I'm logged in. Gonna scroll down. And I'm generating these, again, I do this, so I should be able to share it. Share code. Shared code with 110 students. So now if you hit refresh,
The code should.
it should. Unless you're not logged in. Maybe it's the same kind of different.
Yeah. Who's checking?
You are. Let's go ahead and log you out. And then log it back in.
It should be auto save.
And then scroll down again. Oh my. Okay, let's go ahead and there it is. See? There's the code I have.
See. Thank
Okay.
you.
So you can run that and get credit for it. All right. Now with that out of the way, let's make sure I can do this. Let me go ahead and do this next portion. And I guess, yes? Get to what? This one? So there's two ways. You can either go to Canvas and you can go to your text and basically there's always a link in the textbook. Sorry, a link to the relevant textbook pages. So if you go to your class, you can go to modules and you can go to module 4 is this week. So go to turtle sequences for loops. We're on week 4, so it's module 4. We scroll down and you just click on the relevant portion. Tuesday, Thursday. If you need to get there directly, you go to runestone.academy. You click on textbooks. And then I tell you, oh, we're working on project 5 today. And so we scroll all the way down and click on 5 over here. So we're on project 5. Now, with this problem, we've got to create, as I mentioned, it's basically the exact same thing. The only difference is that there's really two, okay? So first I've imported random just like the other one. And rather than doing chars, because these were characters, I'm going to use the term words because they're words. Otherwise, it's exactly the same. Nouns plus verbs plus adjectives, just like above, right? 1, 2, 3, 4, 5. So let's take a look at the first. So we've got that here, right? I have the import random. We have our sequences, and then we added them together. And now I'm just going to print them out, right? Just to verify what we have. Print. I'm sorry. Let me see. Import random. Random is unused. Yes, it is. That's fine for right now. Okay. Next, make a four-word password. 4 blank in range 4. We're going to do the following four. We're going to do just like we did last time. 4 times word. Sorry, we need to make our accumulator. Password is equal to, and it's going to be blank, right? And what we're going to do is we are going to do word, password, and then we're going to do our use random. Password is equal to random.choice words. Print password. Run. Password plus. I kept resetting password rather than adding to what we had for password. And I'll go ahead and actually put this in the loop for a second so we can see that what we're doing is we are repeat, profession, statement, whisper. So first iteration through the loop added repeat, then it chose profession, then it chose statement, then it chose whisper. Okay. Just feels like I'm getting nouns. Just okay, blue, blue's an adjective. Colony, rare, serving, free. Repeat, tune, extra, tune. It chose tune twice. It's random, it can happen. Processor, add, rock, escape. So we've got ourselves our 4-word password. Everybody see how this was basically exactly the same as the last one? What changed? The names of the variables over here, instead of undercase, instead of letters, caps, numbers, we had nouns, verbs, adjectives, and we added them up into words, right? And then we just changed the 8 to a 4 because it's 4 letters. Now, personally, I'm not satisfied with this because for me, if I'm having 4 words, words have spaces in them, between them. So how can we add in a space between the words? We literally do that. We add a space, right? Everybody see that's an empty space between the words. And now that gets me 90% of the way there. Insert, represent, shape, mass. Right? Let's go ahead and... Okay. Let's go ahead and scroll this up so I can run it. Mass, Temple Mountain headquarters, Little Pale, uncomfortable limit, coordinate, picture, advise, clean, gray, rock, mass, modify, born, resistance, speed, acquisition. All right, so I'm getting Computer Mountain, pale, disaster. Almost like a poem there. Okay. There is just one slight issue. If I copy paste this in and put this in as my new password, and then I go in later over here and I type computer space mountain space pale space disaster, I'm going to be in a world of hurt because my password is actually computer space mountain space pale space disaster space. See how it's got, everybody see the space at the end? So one of two things, you either got to remember that there's a space on the end or we got to get rid of it. This is what we call the fence posting problem, by the way, in computer science. It's a very common problem we come up against. But the idea here is that when you're laying out fences, okay, when we're laying out fences, like so, okay, I've got, say you've got 1, 2, 3, 4 posts. You need, let's go ahead and use equal signs. 1, 2, 3 bits to connect them, right? Got 4 fence posts, and then I get 3 bits of material to connect them with, right? This is a fence, but often in computer science, when we do a loop or something repetitive, we get an extra bit hanging off, right? Right? Because the idea here is that we want 4 posts and 3 connectors. Similarly over here, so there's a couple different ways around that. The way I like to handle it is with something we'll learn later called a slice, which basically says I want to only select a little bit of the string. In this case, the little bit is everything but the last character. The other way to deal with the fence posting problem is actually, this is really silly, but it works. You're like, well, what I've got here is 3 identical things plus a 4th similar thing. So we're just going to do that. We're going to do 3 identical things. And this seems really stupid, but it works. 3 identical things plus a 4th near identical thing. So we handle that last post manually, so to speak. In this case, our posts are the words and the connecting material is the spaces. And now I run it again. And now I don't have, and I've got wish, tissue, constitution, and okay. And I don't have a post after that. I'm going to go ahead and share, though, the version without any spaces with you, which would be this one, so that you'll have that for reference. And then I'll go ahead and share this version that I just did with you as well. So you'll also have that for reference. That way you don't have to frantically try to type everything in and accidentally miss the colon, right? Okay. I'm going to just hit run on this because this is the least interesting part, because it's basically missing the point of the comic entirely, which is that you can, but I'm going to go over the code in it, even though you're probably never going to use this in my class, or you're not going to use this first part of my class, really. We can take some word like this, pool, and we can do an operation, word is equal to word.replace. So there are a bunch of functions that are built into strings. I'll just actually take a moment to play around with this. The first is the dot replace thing, which says given a single letter, we can replace it with a different letter. Pool becomes peel, right? Another one is capitalize, which capitalizes basically the first letter of the string. Right? It gives it proper capitalization. For instance, if I did the pool, the peel. Notice it just capitalized that one. What if I did add a bunch of spaces in the beginning? No, it just literally capitalizes the first letter, which is kind of useful, I guess. Okay. Now, notice how whenever we mess with a string like this, it is word is equal to word dot replace. This is because strings are what we call immutable. It's basically big fancy word saying we can't change strings once they're made. Once you make a string, you can't change it. Don't know why. It's just them rules. Didn't make the rules. I'm just here to report them. So you can't change strings. As a result, anytime you do some kind of operation that looks like it's changing a string, what we're actually doing is making a brand new string, and then we just happen to be saving it in the same place the old string was, right? We're overriding the previous string. We could also just make a second variable like word2 and do it like that. And notice that the original word remained unchanged when we did the capitalize. There's, similar to capitalize, there's a few other things like upper, which makes it shouty case. The pool. And if you do end up with something like this, the pool of doom, if you do word dot lower, it becomes lowercase, right? So there's a number of very useful operations that are built into string, but for your first exam, you really don't need to know any of them, unfortunately. First exam is focused a lot on turtles and for loops. You will get a practice exam. Okay. I don't want Outlook, though. I have Outlook. Okay. So the last part I'll be doing on my own, which is this challenge portion, which goes beyond what we've covered in the book so far. But again, I like exposing you to those kind of ideas here. No, I don't need to set it up. Okay. So, and this is just to kind of demonstrate how easy some passwords can be to crack. So here we have a 4-character password that is composed of only lowercase letters. They could be any 4 letters together. We're just going to start with A, B, C, D, but we could guess it easily. How many guesses does it take to guess the password? Okay? So we can actually write a program to see on average how many guesses it's going to take. So we're going to look at this program. First, it imports random. We know what that's used for. It's used for choosing random thing. Import sys is a bit interesting, and we immediately use it. Sys is short for system, right? SYS. And this sets it for 60,000 with a comment of 60 seconds. This is 60,000 milliseconds, right? And what this is doing is that it is setting an execution limit for the processor. This is in case I mess it up, it's only going to lock me out of the computer for a minute, or the web browser for a minute, rather than until the program ends, right? By default, it's set for 30 seconds on your for everything on Runestone. So that if your program randomly crashes after appearing to run for a while, this is why. Okay? Next is the password we are trying to guess, and we're just using that as an example. We could use anyone as that. Guess number, that's gonna count our guesses. Done is equal to false, while not done. So while loops we haven't learned yet. This is literally your first introduction to something called a while loop. Again, not useful for your first exam. A while loop is the other type of loop. Loops are used for repetition. For loops are used to iterate through something. While loops are basically say we are going to do something until we're done doing it, until this condition is no longer true. And I often do, and this is great because I often write my for loops like this, and my while loops like this, while not done. Done is false, not flips that to true, right? Not false is true. Make sense? So the not operator turns false to true and true to false. Okay? So while we're not done, and then notice that in order to be done, we just simply set done to true, and then while not true becomes false, and so this will stop executing. It makes sense linguistically. While we're not done, do this. If we are done, we're going to stop. Guessed password is equal to blank, your code here. If the guessed password is equal to my password, so that is something we call an if statement, which basically says, hey, if this condition is true, execute this. Again, I find these are all things that would be justifiable to be putting on a first exam, while loops and if statements, but I find we have enough trouble as it is, or enough excitement, I should say, as it is, to focus on the for loops. To just focus purely on for loops for the first exam. Those are a pretty good facsimile, I find. So, if the guessed password is equal to my password, print found it after this many tries, print out done is equal to true. So so basically we are just trying to do this. Guess a password at random. So first thing I'm going to do is I'm going to go up and I'm going to totally steal this bit of code. Letters. Right? I'm going to just steal that letters, scroll back down, scroll back up because I went too far. And what I'm going to do is I'm going to say, I'm going to just add this up here. Letters is equal to this. I don't want to put it in a loop because then I'd just be basically recreating this variable again and again. And wouldn't have any negative impact. It just feels so wasteful coming from my perspective. So what we're going to do is we already have random, so my they call it guessed password, so what we're going to do is we're going to do what we did last time. For blank, we need 4 letters, so I'm going to do the one thing 4 times, which is for blank in range 4. Going to do the same operation 4 times, which is I'm going to take the guessed PW equal to guessed PW, and then I'm going to do random.choice random.choice letters over here, and then that will put together 4 things. So that will put together 4 random letters and put it into that. And then the other thing, there's one last step before I hit the run, which is that we want to keep track of the number of guesses that it took. So what I'm going to do is I'm going to take guess number, right, guess underscore number, and I'm going to set that equal to the number of guesses I had, the previous number I had plus 1. So basically generate a full password. And that's why I only increment it 1 here. I don't have it inside because that would increment my guesses by 4. But putting together 4 numbers is 1 guess. Sorry, putting together 4 letters is 1 guess. So hit run and hope it works, hope it works, hope it works. We'll know soon. Because technically, since it's random, it might not, but it generally, there it goes. 81,437 guesses before it landed on A, B, C, D. If I did wolf, right, as my password, which has the advantage of being an actual word, right? Save and run, how long does it take for it to come up as wolf? Right? It's just trying to find a password by just kind of guessing. This is also why a lot of websites will lock you out after a certain number of attempts. And guessing randomly isn't necessarily that smart because you have to basically go randomly. And you could do repeats, right? But it could take a while. Now, while that's going, let's do a bit of math. How long on average how many guesses should it take on average? Well, first off, how many possible 4-letter passwords are there? So a bit of a combinatorics lesson for you. How many possible guesses are there? Well, as it turns out, you have since there are 26 letters, there are 26 possible choices for the first letter. Then there's 26 possible choices for the second letter. So you have A, B, you have AA, AB, AC, AD. So 26 possible choices that start with A, then 26 possible choices that start with B. If it was a 2-letter password, so that'd be 26 times 26 for 2-letter password. Times another 26 for a 3-letter password, and then times another 26 for a 4-letter password. Meaning that it is approximately 456,000. Time limit exceeded. Not surprising. Now, on average, if we're guessing randomly here, and we assume that we're lucky and we don't have any repeats, after doing this a couple million times, on average, I'd assume basically that we'd find the random password halfway through our search. Divide by 2. So on average, I'd expect to basically hit 228,000. And sometimes we get lucky and find it in 30,000 guesses. Okay? So we can simplify this, by the way, to basically saying 26 to the 4th power divided by 2. Same answer, right? The reason being, though, it's 20, so because it's 426. Now, if I were doing a 5-letter password, right? A 5-letter password over here, it multiplies my result by 26. And another letter gives it another, multiplies by another 26. That's what the exponents mean. And your standard 8-letter password has 1,000, million, 208 billion different combinations. But that's doable for a computer. Although, actually, that's only for keeping it undercase, right? What are we typically looking at? We're typically looking at undercase and uppercase, so that brings us up to 52, plus numbers, gives us up to 62, and then symbols, and let's assume that we're only looking at symbols in the top row, right? Sometimes they put limitations, and so that's another 10 symbols. So that's 72 to the 8th, which takes us firmly out of the billions, thousands, millions, billions, trillions, 722 trillions. But that is nothing compared to basically taking a bunch of random words, let's say they're average 4-letter words, okay, 26, and let's say we just take 4-letter words, 26 to the 16th. The exponent does a lot of work for us. It's hard for us to understand this, but this is if we're just doing four-letter words, right? There are this many combinations of letters if they're all just kind of glommed together, right? That's really big, right? We were in the trillions, so quadrillions. Yeah, it's big. Very big number. Exponents do a lot of work. This is why longer passwords are better, because the length it's the length, not the special characters, that really add to the complexity, right? Let's take a look at that. 72 to the 8th versus 26 to the 9th. So adding in all that complexity is essentially the same as adding in 2 more letters just undercase in terms of orders of magnitude, right? It's much better to just add more and more letters. Hence why I would suggest just, if you've got given the opportunity, use a multi-word password. The other thing I would do is definitely add 2-factor authentication to your accounts where possible. Temple forces you to do this for a reason. And the reason is, it doesn't matter if you are the most paranoid person on earth when it comes to password security. I'm pretty darn paranoid and I can still get got. The issue is, they have to get lucky once. Exactly once, when you're exhausted and your guard is down and you're delirious from lack of sleep. You got to get lucky you got to be alert and on it every single time. So do yourself a favor and pretend that you in the future is a blubbering idiot. Okay? And just simply make life as easy for that person as possible. Put on 2-factor authentication where possible. Right? Make it so that as complicated as you can for these kind of attackers. So even if they get your passwords, it is very hard for them to do anything with it. Got it? Because, that's the other thing. You can be very cautious with your passwords, but if you reuse them and a site decided to store them in plain text, then, and you reused it, then you're in trouble. What does that mean? That is the other thing. What happens with websites and actually storing passwords? If they're doing it properly, when you log in, you're never actually storing your password. Okay? What we do is a bit of what I did my research on, is that they do a hash. Okay? Let's go ahead and do SHA-256 online. Right? It will generate a hash. A hash is a one-way function. It's not completely random, but it's meant to look that way. Say my password is let's go with Taco Cat again. I really like that palindrome. Taco Cat, palindrome. So say that's my password for on a website. Taco Cat never actually gets stored as my password. What gets stored instead is this hash, as it's called. It took it took Taco Cat, ran it through an algorithm, and produced this. And these hashes, what's important is that they are one way, meaning that it is impossible to go from this random gibberish of numbers back to this. It's impossible to reconstruct those things. Okay? That's the important thing about a hash. Okay? So what you do is that when I save my password, when my password gets saved, this is what gets saved on the website. So it never actually has my password. So when I go to log in, how do you log in if it doesn't have your password? Well, when you type in your username and your password, it takes the password again, okay? And then it regenerates that hash and it says, hey, does the hash you just generate does it match this? And if so, it lets you log in. But is it possible to enter the wrong password and get that and log in anyway? Technically, yes, but the probabilities of that are so infinitesimally small, it's ridiculous. And so the way website leaks work is that there's some tricks you can do with hashing and data sets to try to figure out what, how to log onto somebody else's website than the original one. That's why when there's a data breach, you change your passwords anyway if you reuse them. But this is what happens. This is ideal. Then nobody ever actually gets your password. However, not everybody takes a class with Professor Rosen, and so learns that this is the way that things happen. So sometimes people will literally just store the passwords in plain text. I mean, they stored the password directly. So that's the issue. So anyway, there's your brief security lesson for the day. I hope you have a good day. I hope you've been able to stay warm, and I will see you all later.